Hey guys, Ms. Fearon here. Welcome to Unit 4, Notes 1. Our learning target for today is I can factor out the GCF and I can factor by grouping. So the first thing I want to look at is what is a GCF? A GCF is our greatest common factor. And if we pick those words apart, greatest means the largest, and then common factor is the factor that each of them have in common. So we are looking for the largest factor that can be divided out of each term. This can be a number, this can be a variable, or this can be a number and a variable. Here are the steps that we're going to go through today when factoring out the GCF. So we're going to determine what the GCF is first. We are then going to divide that out of each term. And then our final step is to write the expression in factored form, which means we need to write it as the GCF times what would be remaining when we divided it out. So let's look at our first example here. We have 12a squared plus 16a. So I want to figure out, first of all, what number do both of these things have in common? Is there a number? So to do that, I'm going to go ahead and I'm going to make a factor tree for each number. So factor trees are then going to be what two numbers multiply to get to that number. So looking at 12, I always start with 1. Well, 1 times 12 gets me 12. I go to 2 then, 2 times 6. I can say 3 times 4. Because my next number would be 4 and 4 is already in our list, this is my complete list and I'm done with 12. So I'm going to do the same thing for 16. So start with 1 and 16, 2 and 8, 3 doesn't go into 16, 4 and 4, I've rounded back around again, so I'm done with my list for 16. So now I'm going to look at the list and I'm going to try to look and see what is the largest number that is in both of these lists. Well, 4 would be the largest number, so for my GCF, that's going to be the number part. I have a 4. I'm then going to look at both of those. They both have an a in common. An a squared just means it's a times a. So I also know that I'm going to take an a out of both of these. So since I've determined my GCF, my second step now is to divide each term by that GCF. So I'm going to divide each term by 4a. So third step says I write it out as a GCF multiplied what would be left when I take it out. So 12 divided by 4 gives me 3. A squared divided by a is an a. Remember, when you divide, you subtract those exponents. Now I have plus 16 divided by 4 is 4. A divided by a, those cancel. So this would be my final answer. You can always check and think back to Unit 3 when we were multiplying these things through. I would end up with 12a squared plus 16a, which is exactly what I had when I was up in the beginning. So I know that I did it correctly. So my next example here, again, I'm going to go ahead and I'm going to look for my greatest number they have in common, and I'm going to write out my factor tree here. So I'm going to have 1 and 5. Those are the only things that multiply to 5. 1 and 30, 2 and 15, 3 and 10, 4 doesn't go into 30, and then 5 and 6. So my GCF for the number is going to be 5. Now I'm going to look. They both don't have the same variable, so there is no variable that I can take out of this. So my next step tells me that I need to divide that GCF out and then rewrite it so it's the GCF times what would be left. So 5x divided by 5 gives me 1x. Plus 30y divided by 5 gives me 6y. I know I'm done. I could double check to make sure if I distribute this back through, I end up with 5x plus 30y, which is what I wanted. I'm good to go. So now look at the next example. If you're getting really good, you don't have to write out your factor trees of everything. You can just look at your numbers and see what they all have in common. So I have an 18, a 12, and a 9. I know that they all have a 3 in common. So my GCF, the number for sure that I'm looking at that they have in common that I'm going to take out is that 3. Now I want to look at the variables. They all have C's with them. And here's the trick. When you are looking at how many of these do I take out? You want to take out the smallest number, smallest exponent possible. So I have a c to the first, a c squared, and a c to the first. So the smallest exponent is the c to the first, so I'm just going to take out that c. And then I can do the same thing. They all do have a d. I have a d squared, a d to the first, and a d to the first. So the smallest number is the d to the first, so I'm going to take that out. So now what that tells me is my GCF is a 3CD, and that's what I have to divide out of each term. So 3CD, 3CD, and 3CD. So 18 divided by 3 gives me 6. A c divided by c, those are going to cancel. And then a d squared divided by d, remember you subtract, so I still have 1 left. Plus 12 divided by 3 gives me 4. The d's cancel in this situation, and a c squared divided by c gives me 1c. Plus 9 divided by 3 gives me 3. And then both the c's and the d's cancel in this situation. So this is my final answer. I would be done. Go ahead and try the next example on your own. I believe that this is going to be example number 4 for you guys. Go pause the video and then come back and check your work. So when I was looking for the number that they all have in common, the only number that goes into 3, 2, and 1 is 1. And that's okay. So if I looked at a variable, 2 of the 3 terms have an x with them, but the third term does not. So since they all don't have that variable, I can't take that variable out either. So my GCF is just 1. So then I would divide everything by 1, and I would still be left with 3x squared minus 2x plus 1, and I would be done. So now the next thing that we're going to be looking at is factor by grouping. So when we are looking for factored form of an expression, we want to factor to undo the multiplication and distribution. So unit 3, we went over the box method and the FOIL method. That would be to multiply and distribute. Factoring is to undo that. So we're going to get back to seeing our binomials or our factors, which is our parentheses that looked like this down here. Here's the steps we're going to take for factor by grouping then. So step 1, we want to group the terms into 2 groups. Divide out the GCF of each group. Step 3, check to make sure the leftovers match. Step 4, write the leftovers as one factor. And then step 5, write the GCFs together as the other factor. So let's look at our first example and make these steps make a little bit more sense. So step 1, we want to group the terms into 2 groups of 2. So I'm going to group my terms here so that I have 2 terms in each parenthesis. So step 2 now, I need to divide out the GCF of each group. So if I looked at my first set of parentheses here, my GCF, the thing that they have in common, they both have a 1 in common, and then they both have an x in common. If I look at my GCF for the second set, they both have a 4 in common. They don't have an x in common because only one of the terms have that x. So now I'm dividing a 1x out of this guy, and I'm dividing a 4 out of this one. So now if I take that 1x out of that first set of parentheses, I want to write what would be left. So I'd be left with an x, and then a 2x divided by 1x would give me plus 2. I have the plus sign. If I took the 4 out, I would be left with x plus 2. So now we want the inside parentheses to match, which they do. So that's my first set of parentheses. My second set of parentheses then is the GCFs that we took out. So 1x plus 4. So let's go ahead and try that again now with example number 2. So first thing is I'm going to group them so I have 2 sets of parentheses going on. I'm going to figure out the GCFs for both, and that's what I'm going to divide out. So the GCF for the first set of parentheses, they both have 11, and they both have an x. GCF for the second set of parentheses, they both have a 10 in common. So this one I'm going to divide by 11x, and this one I'm going to divide by 10. So now, GCF of the first and then multiplied by what's left. 11x squared divided by 11x gives me x, minus 33x divided by 11x gives me 3. I have that plus sign in the middle, so I'm going to keep that. 10 is the GCF that I took out, so what would be left would be 1x minus 3. The inside parentheses match, so I know that I'm right, so I have an x minus 3 or a 1x minus 3. And then my GCFs are my second set, so 11x plus 10, and that would be my final answer. All right, example number 3 now, we are again going to group. So put our parentheses around our two terms in each group. And we're going to look at the first set of parentheses and we're going to say, what's the GCF that they have in common? Well, with a 2 and a 5, the only number I have is a 1. With an x squared and an x, I know I have an x. So now we're going to GCF of the second set of parentheses. 4x and a 10, the number they have in common, the largest number they have in common is a 2. And they both don't have an x, so that's it. That's all I can take out is the 2. So we're going to divide by the GCFs that I've determined for each set. So looking at the first set, I write my GCF first, and then I write what it is that I have left. So a 2x squared divided by a 1x gives me a 2x. And then a 5x divided by a 1x gives me plus 5. I have that plus sign that carries down there. So now I have a 2 that I took out. If I do 4x divided by 2, I get 2x, and then 10 divided by 2 gives me plus 5. So my first set of parentheses is the 2x plus 5. They match, that's good. And then the second set is the GCFs I took out, so 1x plus 2. That would be my final answer, and I'd be done. So we can go ahead and look at number 4. Again, put your parentheses around your two sets here. And now we have to determine a GCF of each set. GCF. So GCF of my first one, I have an 8 and a 64. I know that the largest number that goes into both is an 8. And I'm going to look and see if they have a variable in common. They have an r to the third and an r squared. So remember, I said when you are taking out a variable, you want to take out the smallest exponent. So I'm taking out the r squared. So now second set of parentheses, the number that a 1r and an 8 have in common is just a 1. And they both don't have a variable, so I can't take a variable out of there. So I'm going to go ahead and divide each thing by what the GCF that we found for that set of parentheses. Divide this one by 1. And now GCF first, multiplied by what we would have left if we divided it out. So an 8r to the third divided by an 8r squared just gives me a 1r. Minus a 64r squared divided by an 8r squared. Well, the r squareds cancel out, so I'm just left with 8. I have that plus sign. The GCF I took out was a 1. R divided by 1 gives me r, and minus 8 divided by 1 gives me 8. So I have the 1r minus 8, or r minus 8, and the 8r squared plus 1. That is my final answer. So go ahead and try the last two examples on your own. Remember your steps that you're taking, and then make sure that you're really careful about what variables that they have in common. Pause the video, try and come back and check your work. So for number 5, I got 3v minus 8 times 2v squared plus 7. And then number 6, I got 8c squared plus 5k squared times 5a plus 4b. If you got either of those wrong, make sure you come chat with me before moving on to the practice problems. Number 6 is very similar to one on your quiz, so make sure you have a really good understanding of what's going on when we're factoring by grouping.